Blockchain platforms. Smart contract development platforms. Module 5. In this module, we overview some platforms for the development of smart contracts, some smart contract programming languages. Module 5. In this module, we overview some platforms for the development of smart contracts. Solidity. Solidity is a programming language for developing smart contracts. It was originally restricted to Ethereum, but other blockchains and Layer 2 solutions have since supported it. Chaincode is the smart contract code that runs on the blockchain network, executing transactions and manipulating ledger state. Programs can be written in Go, Java, or Node.js. Digital Asset Modeling Language, or DAML for short. DAML is an open-source smart contract language for developing distributed applications that define rights, obligations, and workflows. It targets financial and enterprise applications. Vyper. Vyper is a so-called Pythonic smart contract language for Ethereum. The language main goals are simplicity and auditability. Lifecycle of smart contracts. We identify 6 main steps in the lifecycle of a smart contract. First, the contract purpose and functionality are defined. It is then coded using the specific programming language. Next, the code is tested and detected bugs are hopefully fixed. The contract is then published to the blockchain and enters its cruise mode, executing whenever it is triggered to do so, and being monitored. In some cases, the contract might be upgraded or adapted to new scenarios. Security considerations. Security is of paramount importance as smart contracts enforce business logic, and thus failures and vulnerabilities can cause severe financial and reputation damages. Some of the main security best practices are regular code audits to detect vulnerabilities, careful unit and integration testing. Another important task is access control, which should be enforced through strict permission mechanisms. Finally, it is important to have proper support for updates to address potential issues. Best practices for development. Let's look at some of the best practices for development. Complexity is difficult to master and thus should be avoided. Proper documentation, such as comments and usage guidelines, are important. Also, whenever possible, one needs to use established libraries to minimize risks. Finally, as the execution of smart contracts carries cost, development should always have a focus on efficiency. Common vulnerabilities in smart contracts. Smart contracts are prone to several vulnerabilities. One is the reentrancy attack, which exploit a contract's vulnerability to repeated, unexpected calls from an external contract before the initial call's state changes are completed, potentially leading to state manipulation or fund drainage, as it was the case of Ethereum's 2016 DAO attack. Integer overflow, underflow are errors global to programming, which can seriously disrupt a vulnerable application. Mismanagement of permissions can have serious consequences in smart contracts, especially ones that deals with financial transactions. As the name implies, denial of service attacks focus on disrupting services and can have serious brand and financial damages. Future trends in smart contract development. Futurology is always difficult in technologies. Nonetheless, let's have a try. Interoperability across blockchains already exists, although just for specific blockchains. Formal verification based on mathematical proofs is a wider goal for coding. not only for smart contracts. As we have already seen in this course, development of Layer 2 solutions is underway. Such is the importance of improving scalability and reducing costs. Finally, as AI is invading everything, it is expectable that machine learning invades smart contracts. Thank you for your attention.